Now going to start an application looking at area, and I'm going to set up the definition that's going to follow. So if I wanted to find an area under a curve, I can do it in one of a couple of ways, but certainly I want to find the area between 2 and 4. So x equal 2 and x equal 4. I could maybe do it geometrically and kind of do a trapezoid. That would give me a good approximation of that area, if I could remember what the formula of a trapezoid is. Or I could do rectangles. Well, if I did a rectangle on the underneath, what you would see is the area I would find would be too small. If I would do the area and go from the top, then the area would be too big. So we want to try to do as best we can to find an estimate for the area. So as we're looking at it, suppose I just do a single rectangle, and we'll go from the smaller root here. And what would the area of that rectangle be? Well, area is length times width. The height of this rectangle is the function value. So the height would be f of 2. The length of this rectangle is this distance along the x-axis would be 2. So if I look at f of 2, the formula is x squared. F of 2 is 2 squared, or 4. So if I look at area, the height of the rectangle is 4, multiplied times the width of the rectangle, which is 2. And so which is 2, and what this is going to give me is 16. And we notice that I have an error. The error is this: it didn't include all of that area. So it's too small. Well, what if instead what I wanted to do is do 2 rectangles instead? So how would I work that? Well, if I'm going between 2 and 4, I would divide between 2 and 4 and just divide it in half. That would be my 2 rectangles. So that says that if I'm coming from the inside, come up, hit the curve, come straight over. My first rectangle, up, hit the curve, come straight over. Now the base of my rectangle on each base is 1 unit. And if I think about the height of this rectangle, the height is f of 2, it's the y value. The height of the second rectangle is f of 3. And f of x in this case is going to be x squared. So what is the area? The area is going to be the height, which is f of 2, multiplied times the width, which is 1, plus the height, which is f of 3, times the width, which is 1. F of 2 is just 2 squared, which is 4, times 1, plus f of 3 is 9 times 1, which is 4 plus 9, or 13. It's not 8. This is what is wrong. This is 8, not 16. Sorry about that. So that's 8 units. So it got bigger. So it was 8 before, and now I got a better estimate. It's 13, but I still have error. And that's my error. Well, suppose what I do instead is I do the 4 rectangles. Well, I'm going from 2 to 4. And if I want to do 4 even ones, I divide it off here at 3. Then I'll divide it again in half. And now I have 4. So Now, the base of each rectangle is a half a unit. And then I hit the curve, come over, hit the curve, come over, hit the curve, come over. I'm still going to be too small, but the error is going to be less. So what's the height of the first rectangle? F of 2. The height of the second rectangle is F of 2.5, because 2 plus a half is 2.5. This is F of 3. And 3 plus a half is F of 3.5. This would be my area that I'm going to calculate out. So what would it be? Well, the area would be the first rectangle, area of the first, plus the area of the second, plus the area of the third, plus the area of the fourth. Now this would be 2 squared times 1/2, because the function is x squared, plus 2.5 squared times 1/2, plus 3 squared times 1/2, plus 3.5 squared times 1/2. Now if I put it into my handy dandy little calculator, I'm going to have 2 squared times 1/2, I'm going to put 0.5, plus 2.5 squared times 0.5, plus 3 squared times 0.5, plus 3.5 squared times 0.5. And I get 17.25. Notice it's bigger, but I still have some error.